Good afternoon, children. Today we are going to discuss grade 10 part 1 book unit 3 structure of matter. Structure of matter, which is the first chemistry lesson in grade 10. So things in the environment is categorized into two categories. Things in the environment things in the environment can be divided into two categories. One is energy. Other category is matter. So in this lesson we are concerned on matter. So things in the environment is categorized into two forms, energy and matter. In this lesson, we are concerned about matter. So then we'll discuss about matter. First of all, you should know what is matter. It occupies the space. Matter should occupy the space. It should occupy the space, and it also should have a mass. If it is matter, it should have a mass and it occupies the space. So these are the characteristics of matter. If it is matter, it should occupy the space, it should have mass. Then matter can be divided into two categories based on chemical nature and physical nature. So matter can be subdivided based on physical nature and chemical nature. Based on physical nature, we can subdivide matter into solid, liquid, and gas. So these are the three physical forms of matter. Then based on chemical composition of matter, we can divide matter as pure substances and mixtures. Pure substances and mixtures. Pure substances and mixtures. Then pure substances also can be subdivided as elements and compounds. Mixtures, homogeneous and heterogeneous. We'll divide these pure substances and mixtures once again. Now you know, based on chemical nature, there are pure substances and mixtures. So we'll subdivide pure substances first. Pure substances. Pure substances can be subdivided into two categories. What are they? Elements and compounds. Elements, they are purely elements only one single units are there. Only single atoms are there. Only one form is there, like iron, helium, like elements. Compounds, more than one elements are there, like water, H2O, calcium carbonate or carbon dioxide. Even they are known as molecules. Then we mention about mixtures. Mixtures are of two types, homogeneous and heterogeneous. Now if you consider homogeneous mixtures, now if you dissolve salt or sugar in water, salt means sodium chloride. If you dissolve sodium chloride in water, it's a transparent solution. The composition everywhere in the mixture is the same in homogeneous mixtures. But if you dissolve something like soil in water, so there would be sediments down and the upper layer will be clear. So the composition here is different from composition here. So composition everywhere in the mixture is not the same. So it is a heterogeneous mixture. So we discuss about matter. Matter was divided based on physical nature as solid, liquid and gases. Based on chemical nature or chemical composition, we discussed there are two types, pure substances and mixtures. Pure substances, once again, as elements and compounds. Then the mixtures as homogeneous mixtures and heterogeneous mixtures. Then, now we introduce the term elements. Then, atoms are the building units of matter. Any matter, if you consider, now you know the definition for matter as well. Matter occupies the space and have mass. Any matter is made up of atoms. So building blocks of any matter, the building units are known as atoms. Atoms are the building units of any matter, whether it is a solid or a liquid or a gas. Atoms are the building blocks. Atoms are the basic units. Then scientists were concerned about the atoms. So they thought initially those are the tiny particles, building blocks. But later on, scientists found even there are smaller subunits, smaller particles than atoms. So they found atoms are made up of subatomic particles. Atoms are made up of subatomic particles. Subatomic particles. They are of three types: protons, electrons and neutrons. Protons, electrons and neutrons. Protons we can indicate by simple P. Electrons, simple E. neutrons, simple N. Subatomic particles, protons, positively charged particles, electrons, negatively charged particles, neutrons, they are neutral. So atoms are made up of 3 types of subatomic particles. Then the scientists they wanted to know how these subatomic particles are arranged in an atom. So different scientists they brought about different models. So in this syllabus we have to discuss about 3 models. First one is nuclear model by Rutherford. Nuclear model by Rutherford. Second one is the planetary model by Rutherford. Planetary model even by Rutherford. Then the Bohr's model or Bohr model. These are the 3 models in this syllabus to describe how the subatomic particles are arranged in an atom. So first we will discuss about the nuclear model. Nuclear model can be easily described using a football ground. Now it's like a football ground. Now the football is here. So it's a very small area. In that area, protons and neutrons are there. Protons and neutrons are there, accumulated in the nucleus. Very small area, like the football. Now just compare the ground with the football. It's a very small area. It was known as the nucleus. Nucleus. This is the whole atom. So in a very small area, protons and neutrons are accumulated. So that is the nuclear model. And you know, protons are positively charged. Protons are positively charged. Therefore, neutrons are neutral. Therefore, the nucleus is also positively charged. That is the nuclear model. And electrons, they revolve around the nucleus. They revolve around the nucleus. They revolve around the nucleus. They are negatively charged. Further, in this model, he told the number of electrons. Now here we have shown 4 electrons now, are equal to the number of protons. Therefore, now the positive number of positive charges are equal to the number of negative charges. Therefore, atom is neutral. Atom is neutral. Those are the facts described by the nuclear model. That is the first model. Then, Rutherford himself introduced the second model. That is the planetary model. That is the planetary model. Planetary model. It is slightly different from the nuclear model. The nucleus is still there with protons and neutrons, but the electrons are moving around elliptical pathways, different elliptical pathways. Just like the solar system, the planets are revolving around the sun, the electrons are revolving around the nucleus on definite pathways. So this is the nucleus. With protons and neutrons. Electrons are revolving around in different pathways. Then in this model, further these electrons are moving in very high speeds according to that model. The electrons are revolving very fast around the nucleus. Then, based on this planetary model, another scientist, Niels Bohr, introduced another model. He elaborated the planetary model, and it is known as the Bohr model or energy level model. That is the other model, that is Bohr model. He told the positively charged nucleus is there, and there are definite energy levels for electrons to rotate. There are definite energy levels or shells. Shells. First energy level, second, third, fourth. This is the nucleus. So electrons are on these different energy levels. These are energy levels. These are energy levels or shells. Then they were labeled as 1, 2, 3, 4. 1, 2, 3, 4. Or K, L, M, N. And also he told energy gaps decreases. The gaps decreases. The gap from here to here is lower than from here to here. The gap here is greater. Then gap further decreases. Then it further decreases. So from the nucleus to here, then here to here, then here to here, here to here. Energy gap decreases, but energy increases. Energy here, energy here, energy here, energy here. The highest energy is here. Lowest energy is here, but the energy gap from here to here, the gap decreases, but energy increases. That is very important. So energy increases from 1 to 4, but the energy gap decreases. That is a prominent feature of this. Okay. It clearly says when moving away from the nucleus, energy increases, but the gap decreases. That is a very important point. And also there are specific number of electrons which are filled to each level. For first level, there are 2 electrons which can be filled. For the second level, 8 electrons. Third, 18 electrons. Fourth, 32 electrons. So this model is the current model and it is very important. So the nucleus is in the middle with protons and neutrons. Electrons are revolving on specific energy levels. So energy increases from the first level to the fourth, but the energy gap decreases from 1 to 2, 2 to 3, 3 to 4. And there are specific numbers of electrons which are filled to each energy level. So that is about the atomic models.